Hi, we're going to take a look at identifying domain and range from a graph. As you know, because we've been talking about this a ton, anytime we're thinking of domain and range, we're really thinking about input and output, or an x value being input, a y value being output. We're going to take a look at this in the point of view of graphs. And we're going to start off with this graph, which later on in the year when we get into these types of functions, it's going to be a square root function. It's most likely that equation. But if I think about the domain and the range of this, what I want to think about is when I think about the domain, what x values are able to be found on this graph. And if you notice something, this arrow indicates that it's heading that way forever and ever and ever. But this dot right here means we've ended right there. So in a case like this, I think about the x values, and -4 is an x value, and it keeps going this way forever, but it does not go that way. So I have to put down into math language something like -4 onto infinity, or forever. So how am I going to put that into math language? Here we go. Ta-da, there it is. This says basically x is going to be larger than -4, but x is going to be smaller than infinity. All right, so that's a little bit hard to get used to, but remember the other option would be to list -4, -3, -2, -1, 0, 1, 2, 3, and we'd have to keep doing that forever, and I don't think you have time for that. So this is saying x is bigger than -4, or -4 is the end point on the left, and on the right it goes forever, so we use infinity. Now we have to think about the range, and remember when we were thinking about the domain, it was x values that we cared about. When we're thinking about the range, it's y values that we care about. So as I look at this graph, I see that the lowest y value on this entire graph is y value of 0, because that point right there is x equals -4, y equals 0. And the y values, as we travel along this graph, just continue to get larger and larger and larger. It's not going up very steeply over here, but it's still going upward, and it would continue to do that forever and ever and ever. So basically what I want to say is my y values start at 0, then they go to 1, they go to 2, they go to 3, they go to 4, they go to 5, and they keep going forever. And technically I could even be a little bit more picky, because the y value isn't just going from 1 to 2, it goes from 1 to 1.5, or 1.1, or 1.01. In fact, these x and y values would be continuous data, not discrete data. But going back to this, I don't have the time to list 0 up to infinity and every single point in between. So what I'm going to do is I'm going to write it this way: 0 less than or equal to, and I'm going to use y because we're talking about the range, and then less than infinity. So I've described the domain and the range of this function by saying the x values go as low as -4 up to infinity. The y values go as low as 0 up to infinity. And before we move on to the next example, we're talking about -4 being the last x value on the left that would work. I made a simple t-chart, input-output chart here. Of course, I could call this the domain and this the range. And if I were to try to put something in that's left of -4, like let's say a -6, if I plug in a -6 into this equation, I get 2 times -6 plus 4, which is really 2 times the square root of -2. And if you try to do this on your calculator, it's not going to work, because you can't take the square root of a negative number. So anything less than -4 is going to give me a negative inside that square root, thus it doesn't work. That's why that domain ends at -4. Okay, I'm showing you a new example here. In this case, just to spice this up a little bit, let's say that arrow goes forever, but this arrow stops right there. And we'll call that the point 3, 5. Go ahead and pause the video and attempt to write a domain and a range for this function. And then after you write that down, unpause the video, compare it to what I'm about to write, and then you'll know whether or not you're feeling good about this subject. So please pause and write down your best guess for domain and range. Here are my answers. The domain, in other words, the x values that work in this, they go forever in this direction. That arrow says that graph is going to continue on forever. Thus, I can go all the way to negative infinity along this x-axis. And over here, as I travel this way, the last point is right there. That's at x equals 3. The range, my graph, when I think about the y values, never dips into negative territory, but it goes forever this direction. So the y values will continue to get larger and larger. Thus, my y values go from 0 to infinity. Here's just a plain old line. Go ahead and diagnose what you think the domain and the range is there. Pause, and we'll compare to my answer. Here's my 2 cents worth. Since this line continues to travel forever to the right, forever to the left, forever up, forever down, I can describe the domain as forever in the x direction and forever in the y direction. Or when you know it's going to encompass forever in the number world, you could write all real numbers, all real numbers. So you have your choice, math symbolism or a sentence, but this line goes on forever. We're going to do one more example. And here it is. It's a very curvy function. And go ahead and you come up with a domain and a range for this. Pause the video and then compare it to mine. Here are my answers. Let's start with the range or the y values. If you look at this graph, you know that it goes down forever. So it gets as low as negative infinity. The highest point is 4. So y is going to be less than 4, but it goes down to negative infinity. Of course, a theoretical math person would say you never really get to negative infinity. The domain is all real numbers, meaning this graph continues in this direction forever and this direction forever as you go down that way. Another way to think about that, though, would be this. Is there any x value that you're not allowed to plug into this equation? And really, any x value that you think of would be allowed to be plugged into there, so the domain is all real numbers. That's not always the case, remember, because when we did this problem earlier at the beginning of this, an x value of -5 or -6 or -10 was not allowed to be plugged in here, and so that's why that domain would not allow it. By the way, we're writing this a certain way. There's other ways called interval notation that you can write the domain and the range, and we'll cover that later in the year or in a different course. That's the show.